Hi guys, this is the Frogger game from before using MonoGame. In this episode we get player movement in eventually, but we go through a little bit of a journey to sort of handle through model view controller. So we move all the code out of the game state, or at least most of the code out of the game state, into the views and into a player controller as well. We also, at the very start, we also scale up the screen as well from a nice little handy tip that I'll link in the show notes below. Basically, you render to a separate render texture, and then we render that texture onto the screen itself, which means we can actually do special effects where you can like shake the screen and all that kind of stuff. So that's kind of cool. Anyway, let's get started after the fade. So I found this in the web, and we're going to try and implement this. And then figure out if this will work or not. I'm hoping it will. And then this will get us like we'll be able to draw at the actual resolution. We can do all our math at that resolution, but when we draw it, we're actually drawing a completely different resolution. And then we'll start getting the views together so that we're not drawing these all together. And also I want to create a factory for this player model because I want to be able to create the model view controller from this player from a factory. Anyway, we'll get to all that. Hopefully I've explained this all better in the introduction. Okay, so down here is our draw method here. So instead of sprite batch begin, we're going to use a render texture. Now, I don't think we need to create this all the time, so I'm going to create a render target 2D, and basically what we're going to do is we're going to draw, instead of using the back buffer, so you've got your front buffer, your back buffer, and we flip between them, and that's what causes the animation, and also means that we don't get any artifacts. We're going to create another texture. We're going to draw to that texture, and then we're going to draw that texture onto the screen. So it's an additional step. It shouldn't. I can't imagine it will slow down our game any more than it is just now. So our base state here is we're going to have a render texture, render target 2D. Is it render target? Yeah, render target 2D. And then this is going to be, we're going to call this screen. And inside the constructor, we can make that private read only. So, because we're going to set this inside the constructor. So inside the constructor, we're going to say that equals new, that, and then we specify the width, which is 224, and then the height, which is 256. Okay, and I think we need to do the graphic device as well. So that's going to be state machine.game.graphics device. I think that's right. Yeah. So yeah, graphics device, width and height. Okay. So now in the draw, instead of doing this begin end, so sprite sheets. Do I need to create the sprite batch before I do that? I wonder if I need to do that. Probably not. Or maybe I need to, see, it's not very clear here. So the background here is this, so we will go to here. Graphics device. Is that a static method? That can't be static. That doesn't look static. I think that needs to be state machine dot. Do I not keep a reference to state machine? This dot state current state. I don't have a reference to state machine. What? Well, let's fix that. Let's do base state machine. And then inside base state, I'm going to have public state machine get private set. Actually, I think I can just do, oops. I think I can just do, damn it. I think I can just do get, and then I can do public base state machine. Okay, so now we have a base state in there, and now we can do state machine.game graphics device set render target that, and we can clear the background target. So that's the render target, which is screen, and then the background color is color.black, because we're making it just a black color. And then it says, now render your game like you normally would, but if you change the render target, blah, 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 blah. So at the very end there, we do state machine.game.graphics device set render target null. So now everything should be inside screen. And then we can do sprite batch dot begin again, sprite batch dot draw, and then it's going to be the texture, which is going to be screen, comma new rectangle 0, 0, 224 256. Now this should mean that it has, oh, why didn't you like that? Is that better? Nope. What don't you like? What is it? Show potential fixes. Okay. Well, just let me put in what I was going to put in the first place, which is color. White. So we want to basically just show the whole thing. We don't want to do any special effects. Now what this means though is we can have like special effects. So we could actually move the screen, which would be kind of cool. So the net result of this should be that we get exactly what we had on screen. So let's see what we get. Nope, did not like that. Until end has been successfully called. Oh, right, okay. I know why. Because I did not do that end. Okay, so that's the reason for that, is I missed that end there, and now nothing should be different. There we go. So, well, so what? What we can do is we can then say multiply that by 2 and multiply that by 2. And now when we run it, we end up with a double-sized screen, which is kind of cool. And so that means that all the things that we want to do, we can have inside this this area here. But all the math is done inside a very, very small area, so that's good. So we don't need to do any strange calculations. Everything's going to be the same size as it was in the original Frogger. It's just that the screen's going to be slightly bigger when we display it. Now I'm going to make it 4 times the size of that. So I'm going to say private static screen size multiplier equals 4. And is that going to be enough? Because 256, yeah, that's going to be 1,000, isn't it? Okay, let's see what that looks like. Multiplier. Okay, so that's going to make it really big. Okay. So that is 224 times that, which is, if in doubt, use calculator. 224 times 4, which is 896 by that. So I need to go into here, and maybe we do the multiplier in here. Okay, let's do graphics dot desired preferred buffer width equals 224 times 4 graphics dot preferred height equals 256 times 4. I'm going to keep that as the multiples just now, just in case we change them. So this should give us a screen that's tall and wide. Okay, so that's kind of good. It doesn't quite, it does fit in the screen there, I guess. So this works if you've got like a 1080 monitor, but obviously if you don't have a 1080 monitor, then it's going to be too big. So let's bring that down to twice the height. So let's bring it back down to 2, and then inside game state we will change that to 2. So at least it'll be bigger than we had it before. Okay, there you go. That's a good enough size. We can play Frogger at this height. All right. Okay. So now we have that. That means you can do special effects, like you can do like a when you get a frog home, that kind of idea. Okay. Right. So all of this, all of these draw calls, these need to be inside separate classes. They need to be in part of the view class system. So I'm going to have, so background needs blocks, and all of these need to be out of here. So that needs to get done inside. Right. I don't think we need anything other than the content manager for this. So I'm going to say probably add class, and I'm going to call this base view. And base view is going to handle all our drawing things. So I'm going to say that's going to be an abstract class. Public base view content manager, and do we want the sprite batch in here? Let's. Does it matter? I don't think it does matter whether we pass in the sprite batch just now or not. Okay, let's do that later on. So this needs content, and then I need to do public void draw sprite batch. Let's call that SB because I don't want to type in sprite batch dot all over the place. Public content manager get content manager equals content manager. Okay, and we can get rid of all this junk here. So that is our base class for drawing things. So for example, we've got a sprite sheet here for our blocks. So we don't want to, so that's the blocks texture. We want to draw all the blocks as one, don't we? Draw background. So the background is the block. So let's create a background view. So I'm going to say class background view, and this is going to extend from base view. Which is right. And then inside there, instead of blocks here, we're going to take this out here, put that in there, and take that out there, and put that in here. So this is going to be Content Manager. And we're going to take that there, and we're going to take that there. So it does need a sprite batch when you create a sprite sheet, which is unfortunate, which means I need to add that here. So sprite batch, which probably means we need it in here as well. So sprite batch. Well, there was me going for ruthless efficiency. So let me go to here. Oop. And take that out there. Batch. Echo sprite batch. Right, batch, sprite batch, hit. Okay. It won't matter a jot, to be honest. That would be public abstract void. So in other words, any class that implements this class has to also implement a draw method. So I'm going to have private read only blocks, and that's the sprite patch there. And then I need to have public void draw. Yes, it does. Public void draw. Oh, okay. Again, using JavaScript too much. Okay, so public override draw. So inside our game state class, where's all our errors? Let me save that. That should generate errors. Okay, so there's our draw background. So I'm going to take out all of this, and I'll get rid of the draw background part there. And then inside our background view, I'm going to paste that all in, and that shouldn't have any errors. Shouldn't have any errors. Draw home. Oh, right, okay. I've got home as well to do. Where's home? So draw background. We'll come back to that in just a sec. Home. Where's our home? I think we just draw home straight on there, don't we? Yeah, there's home there. So that's also private read only. And that would be content manager as well. Okay. So that should satisfy that. Okay. So now in our game state, instead of having these views, what we're going to do is we're going to now have a background view, and we're going to add those views to the game state. Okay, so we're going to have a list of background views, we're going to have a list of controllers, we're going to have a list of models, possibly a list of models. So we don't need background blocks there. What we do need is private read only list base view views equals new list base views. Okay, that to there. And now inside our constructor, we're going to have views.add new background view state machine.game.content. That would be sprite batch. So we're drawing it onto that sprite batch, and then inside our draw, instead of draw background, what we're going to do is we're going to say for each var drawable, or let's do view in views view.draw. So we're going to have to be careful about how we draw these things. So Frogger should draw on top of everything else. Maybe cars draw on top of frogs. We'll come to that soon. Okay. All right. So we run that. We get that there. So now what we need to do is we need to do the same for all of these components. So when we're drawing the player model, drawing the score, so the player model needs to know about the model. Okay, maybe we do the factory first. And then this one here is the score. So this is the high score. So we need to have that needs to know about the player model as well. So let's add new class, and then this is going to be score view, for lack of a better word, and it's going to extend from base view. An abstract class, constructor, and then for the score needs to know about a font, and it needs to know about the player model as well. The player model is also going to include the high score. Public int high score get set. So it's going to have the high score. So we're going to have to figure out the high score here, but for now I'm just going to put high score equals 1, 2, 3, 4, 5, just for fun just now. And put that in there, that one there, and then this is going to be all the content manager stuff. So really we're just making all the views for this just now. So I'm going to create private font, and then the draw is going to be down here. Where's the draw score? Draw score is going to take that out there. I'm going to take that out, so we don't have draw score anymore, and that's going to go in here. Now you see that this makes this class is getting smaller and smaller and smaller because it has less things to do, and that makes debugging easier, because if you know that the problem lies inside the drawing of a score, then all you need to do is go to this class and go, oh, it's this line down here, line 20. So it makes it a lot easier for you to debug, and it also separates the concern as well. So you've got model, you have view, you have controller. So a good way to go about these things. So we want to pass in player model as well. And what I'll do is I'll put these on the same line, or the same column. Player model, okay, private player model. I'll just call that model. equals that. And then down here, instead of having the high score and all that kind of stuff, we're going to do this dot high score dot toString, and model dot that doesn't have a score yet dot toString. So we need to add a score in here as well. So we'll do public int score get set. Okay. And that's that there. So now we go back to our game state, and instead of draw score, we don't need that anymore. But what we do need is we do views.add new score view state machine.game.content sprite batch, and then player model, which is this one here. Player model. Okay. Uh-oh. Font is null. What? Because it is drawing the player model. So let's not draw the player model. This is the lives. So lives, well, we can draw the lives in there as well. So let's draw the lives inside the score view. I mean, technically it should be inside the like a lives view, but we have the data in there anyway, so let's get rid of that. So this is going to be model.lives. So we can get rid of draw player model. This is getting rid of another line. There you go, boom. We'll rebuild. Okay, so we're back to, well, 1 up 0. High score is 1, 2, 3, 4, 5. Okay, cool. Okay, let's go to that. Let's do private read-only. So all of these private read-onlys are what we should have here, and then we can even make this a little bit easier, because then we could have like a factory, and then we could pass in the factory, and then the factory would then say, okay, here is what makes our game. I'm not going to bother doing that for this, but I will do a factory for this player model, because we need 3 things from the player. Sorry, we need 3 things from the player. We need the player view. So I'm going to create add class player view. Player view. So that is going to be a base view. Abstract class. Add over. Add constructor. That's that there. I need a controller, so I'm going to do add class player. Let's call it frog controller. So I don't have a base class for that yet, but we need something for that. And we have the model. So we have the player model. We have the actually, let's not call it. Let's call it the player controller, because we called everything else player. Player controller, player view, player. Yeah, let's call it player controller, player view, player model. Let's keep it consistent. Rename. Okay, I just thought of something there, and I can't remember what I was going to do. So now we have these values in here. What the heck was I going to do there? Darn it. Let me run it and see if I can figure it out. just by staring at the graphic. That's what I was going to do. Okay, so the issue is we have a content manager that we want to reuse certain content. So if somebody loads a block, we want to remember that that block is in memory and we want to reference that texture. And we don't want to reuse that texture. So what I'm going to do is I'm going to create another content manager. And that content manager is going to remember things. So if we go to background view, so background view loads in the blocks and it loads it in from content manager. So I want to create another content manager that takes content manager as an input, but it remembers, it keeps a reference to these blocks. So any texture that gets loaded. So I'm just going to create a texture manager. Now, do I want to make this a singleton, or do I just want to pass it by reference? Maybe I could put it in it as inside the state machine. Okay, let me do that. So this would go inside general, and then we'll call this content. I call it content management. Asset manager. Let's call it asset manager because content manager's taken. So asset manager. So I'm going to say public asset manager, content manager, content manager, private dictionary string texture 2D, because right now it's only going to be 2D. Goes new dictionary, blah, 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 blah. Let's make that read only. And then we've got private read only content manager. CM equals content manager. Okay, so now we're going to use this content manager instead of the existing content manager. And the reason why is because I painted myself into a corner and I realized that as soon as I used this thing here, because the content manager is going to load blocks. I'm going to use this everywhere and I don't want to reassign. I don't want to have like 20 different versions of texture 2D blocks. Now, I don't know. Actually, that's a good point. Does content manager remember it? XNA content manager. Content manager. Is there no search? No. Class library reference. Content manager. Maybe it does this already. Try content manager as reloaded. Class library reference. Oh, I don't know. But you know what? Maybe it does do that. Let's not bother with asset manager just now. Let's forget asset manager. Let's just willy-nilly let's load these blocks again. It doesn't really matter, to be honest. Okay, let me just grab that there. And let's go to player view, not for this example anyway. And I'm going to say private read only sprite sheet blocks. Okay, and then draw is just going to draw whatever the current frame is. So in our player model, we need to pass that in as well. So player model model, model equals player model. Private read only. Oof. Player model. Model. So in draw, we want to draw the frog at the current position. We don't have any of that, so if I go to models, we need to know the current position. So public vector 2 position get set public int frame equals get set. Oops. Set public bool mirrored get set. Okay. Maybe we can do something clever here, but yeah, let's leave it as that. So the reason why it's mirrored is because if I go to content, I double click blocks, and then we load that up, you'll see that there's standing, the standing, like just the frog standing on its own, is just one movement, is one direction. It's pointing upwards, there's no pointing downwards. And then similarly moving left, there's only a left movement, there's no right movement. So yeah, so we need to figure out how to do that. However, for player view, I'm just going to draw at a particular point. So I'm going to say sprite batch dot draw, and then it's going to be whatever the texture is. So it's a sprite block anyway. Blocks dot draw, and then it's going to be model dot position, and then model dot frame. Color dot white. So this is going to draw a frog at position 0, 0 on the screen, which means it's going to be the top left hand corner. Well, it would be if we'd actually added it to it. So let's do that again. All right, so let's go to here. So this is us drawing it on top of the background layer, on top of the score layer, and so it will draw on top there. So we do views dot add new player view state machine dot game dot content comma sprite batch comma player model. There we go. Okay, so now it will draw on the top left hand side of the screen. There you go. So it hasn't drawn a frog because the frog is not that. So the frog itself is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 16. So that's 15, 31. So 32. Let me write this down. So that's 32, 33, 34, 35, 36, 37, 37. So 32, 33, 30, 32, 33, 34. So 34 is the top one, and then 37 is the left one. Top, left. Okay. So if we go back to our model, and I say frame equals 34. So when we run this now, we should get an up facing. There we go. There is our Frogger. So we need to drop Froggy in at street level. okay, because that's where he's most comfortable, is down there. Okay. So the starting position is going to be, where are we? So it's going to be what, 240 down? So let's try position here. So position equals, and then it's going to be 0,240 down. Think we can do that? No, we can't. New vector 2. That was worth a try. Try to make it more JavaScripty. There we go. So 0 long, 240 down. Okay, so it's not 240, so that's going to be 240, 230, 224, 224. And then it's going to be 16, 16, let's see, what is it, 224? 224 divided by 2, 16, 224 divided by 2, 112. So 112 should put us roughly in the middle of the screen. Okay, that's not bad. I think that is actually pretty much middle of the screen. So that would be, well, let's say 16 times 8. I don't know what 16 times 8 is. No, that's too far. 16 times 5. I think that probably puts us probably in a good position. No, let's try 6. There you go. Okay, that looks good. So that's us, our little frog is in there. So now what we want to do is we want to be able to control that little frog and make him or her move up the screen. So the way we do that is we'll do controllers, player controller, public player controller, player model, that's actually player model, isn't it? Player model equals player model. Read only model. Okay. Public void update float delta time. So our controller gets an update, which makes sense. So we're going to have to pass in the update. So let's have a new item. Let's have an MVC controller. It's a horrible interface name. Interface void update float delta time. Let's just call it iController, because we're really kind of plugging the name in that, or plugging the type in that. I don't like that idea. So that's good. And then, oops. And then this is going to implement. What am I doing? Okay. That's right. And then inside our game state, we're going to have private read-only list controllers equals new list controller, and then controllers these get added in here. So we can do controllers.add new player controller player model. So we're only creating a controller for the player model. And then inside our update, we do for each var controller in controllers controller.update delta time. So now we're updating all our controllers at the same time, and that's all very neat. We don't need to go through anything. All we need to do is just add a whole bunch of things in here. And again, like I said, you could replace this with a bunch of factories, and it would make everything a little bit cleaner. But we're not. At least not right now. Maybe when it gets a bit hectic. Right now it's 85 lines of code. I'm kind of okay with that. In fact, we don't need any of this stuff here. This is going to remove anyway. So lives remaining, we've got that there. Do we need font? Do we need that? That's not used anywhere, is it? Nope. That can go. Private, read only. That's a keeper. So that can go up there. And then we can get rid of general. And then everything is good. Okay. So for moving up, and we're going to use the arrow keys to move up and down. So if we go to player controller, so player controller, what do we want to do here? I want to know where we're moving. So, okay, let's just do the positional stuff first of all. Okay, so if game controller, how do we do this again? One sec. Memory like a sieve. Where are we? Getting started. Maybe reference content. I want content. Design graphics input. Gamepad. Static class gamepad. Okay, so inside here we do gamepad dot get state player index dot 1. Oh yeah, that's right, you got to do is a state. It's all coming back to me now. And then we can get rid of this, because this is just clutter. What am I doing? Okay, so if state dot is button down, buttons dot, and this is the, well, I mean, I guess I could use, I have my handy controller here, so I guess I could do that. But I was kind of thinking more just the gamepad. Oh no, it's keyboard. It's keyboard. That's why. Ugh. Var state equals keyboard dot get state. If state dot get pressed keys. Oh, okay. Var pressed keys equals state dot get pressed keys. If pressed keys dot contains keys dot let's do up. Model dot position equals new vector 2 0 comma minus 16. So if let's do cooldown here as well. So private, let's just do that as a static. Private static int float move cooldown period equals 0.1. So we don't 0.2. So we don't want the player to move if they're outside that cooldown period. And then we'll do private float move cooldown equals that. So the reason why I want to do that is because I don't want you to like just hold the thing down, just and the frog just leaps out of the screen. So I want there to be a cooldown there. So I'm going to say if cooldown is greater than 0, move cooldown minus equals delta time, return. So in other words, get out. I'm not interested. Move cooldown equals 0. So if we're inside that cooldown period, then we immediately exit. So we subtract from that, we immediately exit so that it doesn't keep hammering us. And then I'll say move cooldown equals move cooldown period. So that means that we're not like hammering up. So it means you can also hold up and it will move slowly up the screen. It'll probably move quite fast up the screen just now, but we can tweak the cooldown period. So if I press up, you see that the frog is now moving slowly-ish up the screen. So that's good. So there's no animation on it yet. So let's do the alternates of that. So else if pressed keys dot contains key dot down, model dot position plus equals new vector 2 0 comma 16. Move cooldown equals move cooldown period. Then we'll do the same thing for the X. That would be left, and that would be minus 16, and that would be right. Okay, so now we should have four-way movement. Except we don't have four-way movement because I don't know how to do things anymore. What am I doing? Why am I doing this wrong? So that's on the horizontal, so we need to change the X values. Alright, okay, that should fix that. Okay, so we can go left and right here. So we shouldn't be able to go beyond that, so we'll fix that in just a sec. And we shouldn't be able to go down there, we'll fix that in just a sec. But for now, we've got a frog moving around the screen. And we can actually can't get them into home. So that needs to be centered. So I guess that is going to be, maybe it's on the 8. Oof. Oh, maybe it is on the 8. Oh, hang on a minute. Let's do private static float distance equals 8. So let's do distance. So instead of having that, we'll do that, that, and that. Okay, so now distance, take a wee drink. Okay, so it's a little bit slower, but it also means that you can line up and go into the home. So that's good. And I think that's around about the right speed there. Now again, I just want to reiterate the beauty of this is inside this code there is no drawing. There's nothing getting drawn here. All the drawing happens inside player view. And player view just takes the position, the frame, and then the color. And so if we go back to our controller here, you see that we're changing the position. So we don't draw anything inside this code. This code only updates the game state. Okay. So yeah, that's good. Okay. All right. Now, what do we need to do? We need to animate that movement. We need to figure out what way they're going. So if they're going up, then that's okay. But if they're going down, we want to mirror it. So we want to say model dot mirrored equals false if they're going up or if they're going left. Okay, but if they're going down or they're going right, we need to mirror them. And then we also need to animate from left to right. So we need to animate from, going back to here, we need to animate, so if they're going up, we need to animate from 1, 2, 3, and then back to there. So it's got to be start here, and then 1, 2, back. And then similarly, if we're going left, we need to do 1, 2, 3, and then back. So, okay. All right. And that's got to be done inside that cooldown period time. Okay, that's the next bit. Well, actually, the first bit is to mirror where we are there. So inside our sprite batch, we don't have a mirror. Where's sprite batch? Where is that? How do you do this again? That's not the one. Yeah, that's okay. Sprite sheet. Okay. So I'm going to go to sprite sheet and we want to add draw color, and then we also want to say bool mirrored. So we're going to say mirrored equals false, but if it is true, then we want to draw that's the rotation. Can we get away with just doing rotation color? I don't think we can. Color rotation. I think we are doing that. Scale, that's the one we want. So we want to do scale. So actually, that's what we need to do is instead of mirror, we need to have scale. So we're going to do vector to scale, which is trickier. Okay, let's do public void draw vector 2, position, int frame, color, color, vector 2, scale. And then we'll take this out here, paste that in there, and then we'll do draw, position, frame, color, new vector 2, 1, 1. So we're scaling by 1, which is the scale. And then we can pass in scale here. So that would be position, vector 2, destination rectangle, new rectangle, position dot x, position dot y, cell width, cell height. Okay, what? So what? Destination source. Position. I don't want that one. I want. So this is texture, position, source rectangle, color, and then rotation, origin, and scale. Okay, so rotation, origin, and scale. Rotation, origin, and scale. Rotation, origin, and scale. And then the other one is 0. 0. What is it not like? I'm pretty sure I'm giving it what the parameters it's looking for. Okay, so it's looking for texture, position, source rectangle, color, rotation, origin, scale, sprite effects, and layer depth. Sprite effects, none. Ah, there we go. Ha ha ha. So we don't need scale. New vector 2, 1, 1. And then it's going to be sprite effects, and then that's going to be and that's going to be none. Okay. What? What is it? I swear it's doing the right thing here. Texture 2D, position, source rectangle, color, rotation, origin, scale, effects, layer depth. Does it just not know that it's doing the right thing? Ugh. Okay. Compiled. It's fine. Everything's good. It's fine. It's fine. So sprite effects is going to be part of the model. Not particularly happy about that, but public flip. Okay, I'm sure there's probably a better way of abstracting it than this, but this will help. So for this one here, mirrored, this is going to be flip equals normal. And then that's going to be normal. And this is going to be vertically. And then this one is going to be horizontally. And so that means that when we move, we should end up with the right movement. So press up and then press down. Because I'm not doing the right one there. So I need to do that inside player view. I need to pass in color white, and then I need to pass in model dot flip. Okay, so now it will flip. So press up like that, and then press down, and you see the frog goes down, and then up, it goes up, down, and then we need to change the left and right ones. So the frame, we need to do the frame animation. So when you move, we need you to do, we need the frog to move in a particular way. So that's going to be in here. Okay, do we have a vector 3 dot? Ah, we do. Cool. Okay. So let me do. Where I got here. I want it to be start frame, end frame, and then a third of the way along. Actually, it's 4 frames. So it's you start on that frame, you move to that frame, 2, 3, and then back to that frame. So it's going to be start frame, 2 frames in the middle, and then the end frame. So at position 0, it's whatever the start frame is, and then back to there is going to be whatever the start frame is again. Then we get 2 frames in the middle. Okay, so one at 20, what would that be? So one at 0, what would that be? Yeah, it's like a third of the way. Yeah, okay. Okay. Just trying to think whether we do it inside here or not. Alright, let's do it as a separate class. So inside controllers, I'm going to add another frog animation. And then frog animation is going to take public, and then it's going to take in frames, private, read only, frames, if, let's do public, well, you know what, it doesn't matter. In this case, it doesn't matter, because if we pass in frames as an array, it doesn't matter what those values are. So we can do public void update float delta time. So current frame, public int current frame get set current frame equals frames 0, and then slice, I guess, equals 1f divided by frames dot length. Private float slice equals nothing. Alright, so every time we get to a new slice, we increment the number of frames until the frame is greater than or equal to there. So that should fix that, I think. Okay, so I really just want to count up to that delta time. Let's say frog animation, and then we need to duration as well. Frog animation duration. So every time we count up, we change the frame. Am I making this more complicated than it should be? Probably. It's just the way I am. It is actually sometimes difficult to think while you're on camera. Maybe what I'm going to do is, no, people like this. Me struggling away thinking about this stuff. Okay, so what I want to do is, when I get past in delta time, I want to say if current time equals slice update. All right, so I'm going to do what do we got? Private float current equals 0. So I'm going to say current plus equals delta time divided by, and then we need to have our duration as well. Private float duration. Duration equals duration divided by duration. If current is greater than or equal to slice, slice equals slice minus current equals current minus slice. Current frame equals actually, hang on a minute, get private int current frame equals 0. So current frame is equal to turn frames current frame. That current frame equals 0. Yeah, we're doing current frame equals 0. So so that means current frame plus plus. If current frame is greater than equals frames dot length, done equals true. Current frame equals frames dot length minus 1. And then we're going to have public bool done get private set. Okay, this is probably a little bit of overkill for this, but this will advance the frames from left to right and then mark it as being done. So now what we have is, instead of inside player control, instead of move cooldown, what we have is if, let's call it private frog animation, if animation is not equal to null, animation dot update delta time return. And animation dot done. So if it's not equal to null and it's not done, update it and return. Otherwise, we want to do this thing in here. So instead of that position, what we also want to do is we also want to animate the position of the player over time. Let's do the animation just now. No, we need to do that as well. Darn it. Okay. So if we're doing that, then we also want to animate the player. Okay. So let's do frog animation, and then we'll do so flame duration, and then we'll have vector 2 start, vector 2 end. Okay, and then we'll have private float position count, position time. So we'll have position time there, and then we'll say position time plus equals delta time divided by duration, vector 3 var, current position equals, actually we can just do model, oh, we don't have model, do we? Let's do public vector 3 to position get private set. So then we say position equals vector 2 dot lerp, and then this is going to be the start position, start, and end, and then position time. And that's going to update the position. And what else we need to do? Oh yeah, we need to do private vector to start, private vector to end. So that's our start and our end. And so we want to update that. Then we want to say model.position equals animation.position. Model.frame equals animation.current frame. And then at the end there we say animation equals null because we want to kill it. We don't want to do anything beyond that. And so for this one here, we're now going to try and for each one of these states, we now need to figure out where what animation we need to build. So actually, maybe what we can do is let's do that as delta. That there, and then we can say start equals start, end equals start plus delta. So whatever that is, we just pass that in as this new thing here. So we're adding to that. We're always adding to it basically. Okay, so we want to do. So when we move up, we're going to move from 1, 2, 3. So that's, what is that? 32, 33, 34. 32, 33, 34. So that's 34, 33, 32, 34. Whew. Okay. So that would be, take that out there, move cooldown. We need that one. We don't need this one. So hopefully that will give us red squigglies everywhere. Okay, that's good. So we can say animation equals new, frog animation, and then the frames are going to be 34, 33, 32, 34. The start, that needs to be new int. There. Then the start is going to be model.position, and then the delta is going to be new vector 2, 0, negative distance. And then the duration is going to be move cooldown period. So whatever that cooldown period is going to be. So let's move this back into frame. So we don't need that. We do need to set the flip though. That still needs to get set. We don't need that. So now we need to change that for all of these. So I'm going to do that just now. So down is going to be the same thing, except it's going to be flipped. So we don't need that. We don't need that. We don't need that. But now we're moving in a positive direction. So we have our distance there. So if I just comment this out just now, so even if we do the up portion of it, we should get our animation. That should move the frog up the screen. Fingers crossed. Okay. Well, that didn't work. Stack Overflow. Whoopsies. That would be the wrong thing. Whoops. All right. Let's try that again. Okay. a bit floaty. Yeah, it's moving left to right because I don't have any restrictions on it. There's no cooldown period, but that looks okay. And we're going up and down. All right. I don't think the movement's quite right. It's something we can work on, we can fix. But it's looking okay. Okay, so this one here, the left animation. Okay, so this is going to be animation equals new frog animation, new int, and then it is 34, 35, 36, 37, so that would be 37, 37, 36, 35, 37, like that. And then the start is going to be model.position. And then the delta is going to be that. And then the duration is going to be move cooldown period. Okay, and then the same thing for this one here, except the distance is going to be distance, obviously. And okay, so now all right. Okay, I'm going to analyze the video for Frogger because the movement looks a bit weird. Like I'm pretty sure that should end up. Like these are all in bounds of 8, so unless I've got this here wrong and it's on a bounds of 4. Yeah, I think this might be in the wrong position. Because that should be in the middle, I would have thought. Because this works. Even that's not quite centered now. Is that centered? Let me fix it. So I think it's drifting because it's slightly out of position here. So the very end there, I'm going to say if it's done, let's say position equals end. And then let's say if done, return. So we don't want to keep doing it if it's finished, and we're going to mark it as being that's the end because I think there's a bit of a drift. It's like getting out of sequence when it finishes the movement. That should be centered now. Yeah, see that's centered now. At least it was centered. Yeah, seems to be still drifting. Let's look at the video for Frogger. All right, let me look at the video for Frogger offline rather than wasting you guys' time with that. Okay, I think I'm going to end the video there because that's quite a amount of time there. So yeah, I think we're in good shape now. We have the views, we have the controller, So again, you can see the controller here is very short. In fact, we can get rid of half the code that we don't even use. We can get rid of that. And we can get rid of that. And then what we could do is we could even get rid of these things as well. So for these states, we could make that as like a hard fast animation. We could make that as a factory. Do we want to do that? Let's just leave it just now. Let's not get obsessive with this pattern. Model view controller is good enough for this game, for what we want it to do. And then we have our player model here, obviously, and we have our player view, which is just drawing whatever it's told to draw. It's very, very simple. In fact, we can get rid of half the code here. And you can see there's like 30 lines of code in here. In fact, not even that, it's 9 to 29, so 20 lines of code. Most of it's set up, and then the actual thing that draws it is this one line. So if there's a problem with this one line, it's one line of code you got to look after. The difficulty comes in that you have multiple classes now doing one particular job, whereas before you would like mash them all together into one single big class. But if you do that, it makes like if we had an issue with, like, for example, the score or the players' lives being displayed, then we would have to look inside multiple classes to figure that out. Whereas we can just go straight to, oh, that's where the score, that's where the HUD information is held. So yeah. All right, I'm going to end the video there. Seems like a good enough place to end it. Okay, that went on a little bit longer than I thought it was going to take, so apologies for that. But I wanted to get the project in a good state. So we have player movement in, we have the animations in. So the next time that we go up with this, we'll actually, there's one more thing I wanted to do. Let's do that just now while I remember. So let's go back to the code. 1 second. Just one more thing. I feel like Columbo here. Okay, so player controller. I want to clamp it so that it's not hitting the left hand edges. So actually, let's leave that for next time. Yeah, I know. Sorry. I was thinking of something else. Okay, if you like this video, thumbs up. If you didn't like the video, sorry about that bit there. Thumbs down. Please share the video. Let other people know about it on social media, Facebook, all that kind of stuff. I'm on Twitter at Codehoose, CODEHOOSE. If you want to follow me there to get timely reminders. I know that notifications and all that kind of stuff for YouTube is now gone. So I don't know what's happening with that kind of stuff. So I tweet out when I have a video. Similarly on the Facebook page as well, I'm Codehouse there as well. So yeah, thank you all for stopping by and watching my inane rambling, trying to resurrect this old video game. Until next time, thank you all for watching and keep coding. Bye bye.